Dear students, welcome back to our channel. ఈ ప్రశ్నకు బదిలేది. Now let us discuss about quantum numbers and their importance in this program. The first question of this program is, which quantum number describes spatial orientation of the orbital? N, principal quantum number, azimuthal quantum number L, or magnetic quantum number ML, or spin quantum number MS. So, if you know the quantum numbers and their importance, then only you can answer these questions effectively. So, the C is the correct answer for this. Later I will explain how the C is the correct answer. Next one is, how many electrons can be accommodated in M shell? A 2 or B 8, 18, 9. The answer is C. Somebody may know, please see. Number of orbitals present in nth orbit, small n or n square or 12 plus 1 or 2n square. The answer is n square. Next question is, G subshell contain dash number of orbitals. G shell, we know SBTF, but the G is there, SBDFG. G shell contains how many number of orbitals? If G shell is assumed to be there in the atom in an orbit, so how many orbitals it contain? So, 9, 3, 5 or 7. So, 9 is the, that means A is the correct answer. Next one is, which quantum number do not depend on other quantum numbers? Principal quantum number or azimuthal quantum number or magnetic or spin? The actual answer is spin quantum number, D. We can know while discussing the quantum numbers concept. After that you can know the answers, you can do the answers with your own. So, number of degenerated orbitals present in F subshell. You know, the degenerated orbitals means equally energetic orbitals in a subshell. Equal energetic orbitals in a subshell are called degenerated orbitals. So, S contains 1, P contains 3, D contains 5 orbitals are there, F contains 7 is there, this one. So, D is the answer for this question. Which of the following is correct set of quantum numbers for 3D z square 1 electron? 3D z square 1 electron. So, here n is equal to 3, L is equal to 2, M is equal to 3, S is equal to plus of. The second one is n is equal to 3, L is equal to 2, M is equal to 0, S is equal to plus of. C, n is equal to 3, L is equal to 3, M is equal to 3, S is equal to plus of. D, n is equal to 3, L is equal to 0, M is equal to 0, S is equal to 1. The actual answer for this question is B. N is equal to 3, L is equal to 2, M is equal to 0 and S is equal to plus of. Next question, orbital angular momentum of dumbbell shaped orbital. Orbital angular momentum of dumbbell shaped orbital. H by root 2 pi or root 6 into H by 2 pi or simple H by 2 pi or 0. The answer is A, H by root 2 into pi. So, the answers, somebody may know the answers, but the actual answers, the rational thinking and the predicting the answers can be known only after knowing the concept of quantum numbers and their importance. So, let me discuss the quantum numbers. the quantum numbers are, what is meant by quantum numbers? What is the use of quantum numbers? So, it was the 4 quantum numbers were proposed to locate the electron in an atom and know the energy of the electron in an atom. It was proposed 4 quantum numbers, that is nothing but the address of the electron in an atom will be determined by these 4 quantum numbers. For example, a person is there in some village. So, if postman wants to give a letter to that person, then so how many clues should know the postman? The first one is state, you should know the state, Andhra Pradesh or Telangana or any other state. You will see that is the one clue to locate you. Next one, the district, you will see the district. District is the another clue. Suppose Srikakulam district, you are present in the Srikakulam district in one village. So, then the second clue is to predict you, to identify you is district, that is one quantum number. Third one is mandal, mandal is the another quantum number, and fourth one is the small village in the mandal. So, that means to predict, to locate you in that village. So, how many quantum numbers are required to for the postman? So, 4 clues are required to locate you. Similar way, to locate the electron, whether it is first orbit or 1s or 2p or 3 and 3d, like that. So, in which orbital that electron is located, what is the position of the electron in an orbit. So, everything and the energy also, everything you can know by knowing these quantum numbers. The quantum numbers were proposed by various scientists. Let us discuss the quantum numbers. The first quantum number is, there are 4 quantum numbers. One first quantum number is principal quantum number, principal quantum number. It was proposed by Niels Bohr. It was proposed by Niels Bohr. It is denoted by small n. It describes the size and energy of the orbit or shell. It is called principal quantum number. Principal quantum number, what is the importance of principal quantum number? It indicates the size of the orbit and energy of the electron or orbit, energy of the electron or orbit. So, it is the importance of the principal quantum number. So, what are the values by our n takes, our principal quantum number takes? It should not be equal to 0. It tells the orbits around the nucleus in an atom. N is equal to 1 from the nucleus to the other side, the external side. N is equal to 1, that is k shell, k orbit. N is equal to 2, second orbit, that is L shell, that is L orbit. N is equal to 3, that is M shell, or you can say M orbit. N is equal to 4, N shell. N is equal to 5, O shell, like that. So, these are the orbits. They are numbered, that it takes 1, 2, 3, it should not be 0, it takes 1, 2, 3, 4, etc. They are called K, L, M, N shells respectively. As n value increases, the size of the orbit, the size of the atom increases, and energy also increases as you move away from the nucleus. So, n value increases, as n value increases, the size of the orbit increases. So, now it also indicates the number of subshells in an orbit. Later we know n, that is equal to n, number of subshells. For example, the first subshell contain one s orbital, the second subshell contain s and p 2 orbitals, the third subshell contain sp,d, fourth subshell contain sp, d, f. So, the number of subshells in an orbital is equal to n. The number of orbitals present in nth orbit is n square, Number of orbitals present in nth orbit is n square. So, when suppose take one s orbital 1 in s p in second orbital, second orbit, s and p are the subshells, s contains 1 orbital, p contains 3 orbitals, third s p d. So, S1, P3, D, F5 orbitals are there. So, 9, that means 3 square, 4 square orbitals will be there in the fourth orbit. So, number of orbitals present in the nth orbit is n square, and number of electrons that are accommodated in the nth orbit is 2n square, 2n square. So, 2n square is the n square orbitals are there, each orbital contains 2 electrons. So, the total electrons that can be accommodated in the nth orbit are 2 into n square, 2 into n square. In first orbit 1 square, second orbit 2 into 1 square 2 electrons, second orbit can accommodate 8 electrons, 2 into 2 square, 3 into 2 square, 2 into 3 square, 3 square is equal to 9, and 2 in 9 into 2, that is 18 electrons can be accommodated in a third shell, fourth shell 32 electrons can be accommodated. If you want to write all these, but you can simply, while giving the essay question, simply write up to this, and the importance, the denotion, the values taken, and this may be, you can write advanced way. In the advanced way, you can also write these points also in the while writing the principal quantum number. Next one is orbital quantum number or azimuthal quantum number or subsidiary quantum number. Orbital quantum number is also called as azimuthal quantum number and subsidiary quantum number. Subsidiary means it supports the principal quantum number. So, it is called subsidiary quantum number. It is denoted, it was proposed by Sommerfeld, denoted by small l, and it describes shape of the orbital, shape of the orbital. For example, what type of values it takes? It takes values, it depends on n, it takes values from 0, 0, 1, 2, 3, etc. up to n minus 1 values for every given n value. For example, n is equal to 4, it takes 0, 1, 2, 3 up to n minus 1. If n is equal to 3, 0, 1, 2 only. So, how many values it takes? It takes n values. L takes n values, but it starts from 0 and ends with the n minus 1. So, for how it is, it has the shape, let us see. Suppose L is equal to 0. It is a spherical in shape, s orbital spherical in shape, and if L is equal to 2, L is equal to 1, it is called p orbital. It is a dumbbell shaped orbital, If L is equal to 2, it is double dumbbell shaped d orbital. D orbital is double dumbbell shaped. L is equal to 1, L is equal to 0. For s orbital, L is equal to 0. For p orbital, L value is 1. For d orbital, L value is 2. For f orbital, it is a complex in shape. F orbital is L value is 3. Let us see some k shell. For example, first shell, let us see, take n is equal to 1 shell. What are the L values? L value depends on n. L takes only n minus 1, 0 to n minus 1, that is equal to 0 only. It is called s orbital. So, only one orbital is there in that particular shell, that is called 1s, because it belongs to first shell, 1s orbital. For example, you take L shell, n value is 2, L is equal to 0, 1, because it starts with 0 up to n minus 1, 2 minus 1, 1, 0 and 1. If L value is 0, that is s orbital. If L value is 1, that is p orbital. L value is 1, p orbital. So, s and p, two subshells are there. These are called subshells also. It indicates the number of subshells present in an orbit, two subshells. They are called, because it belongs to 2s, 2p. They are called as 2s second s orbital in second shell, p orbital in second shell, 2s, 2p. M shell, n is equal to 3, L is equal to 0, 1, 2 only. It won't take 3. It won't take 3. 0, 1, 2 up to n minus 1 values. If 0 is there, that is s orbital. If value is 1, that is p. Value is 2, L value is 2, that is d. So, total 3 subshells are there. 3 subshells are there in the third shell, third orbit. They are called 3s, 3p, 3d, 3s, 3p, 3d. 3 subshells are there in the M shell. N shell contains n is equal to 4. For n shell, n value is 4. That means it takes from 0 to 3 only. It won't take 4 up to n minus 1 value. So, L is equal to 0, 1, 2, 3. 0 is S, 1 is P, L value is 2 is D, L value is 3, that is F. So, total 4 subshells are there, subshells, suborbitals, suborbits are your subshells. In the fourth shell, how many subshells are there? 4 subshells are there. 4s they are called 4s, 4p, 4d, 4f, 4s. So, there are 4 subshells are there present in a they are in the n is equal to 4th orbit. Let us see, let us predict, for example, simply note for s orbital L value is 0, for p orbital L is equal to 1, for d orbital L is equal to 2, for f orbital L is equal to 3. Let us see NL values for 2p. 2 is the n value 2, second orbit. P L value is 1. P is equal to L value is equal to 1, for P L value is equal to 1. For 3s, n is equal to 3 because it belongs to third orbit. The S for S L value is 0. For S L value is equal to 0. 3d, n is equal to 3, L is equal to 2. For d orbital L is equal to 2. For example, 4f you take, n value is 4, L value for f orbital L is equal to 3. For f orbital L is equal to 3. So, this way you can predict NL values for a given orbit, given subshell. 2p, n is equal to 2, L is equal to 1, p because p. The first one is indicates the orbit number, and second one indicates the subshell value, L value, subshell. So, now the magnetic quantum number, the third quantum number is magnetic quantum number, ML. It is denoted by ML, sometimes M. It was proposed by Lande, denoted by ML, denoted by ML or M. It describes spatial orientation of the orbitals, not subshells, orbitals. In a subshell, there are orbitals. It was proposed to explain Zeeman and Stark effects. Lande proposed this magnetic quantum number in order to explain Zeeman effect and Stark effects. What is Zeeman effect? Zeeman effect is splitting of spectral lines. Splitting of spectral lines. Lines in the spectra are splitted when the atom is kept in the strong magnetic field. That phenomena, that observation is called as Zeeman effect. Similarly, when an atom is kept in a strong electric field, then also the splitting of spectral lines happened. That phenomena, that observation is known as Stark effect. Stark effect. So, in order to know the splitting of lines, why the splitting of lines happened, is proposed to explain that it was proposed. Lande proposed this quantum number. This quantum number is denoted by M. It depends on L. It depends on L. It takes values minus L to plus L, including 0. Minus L to plus L. L is equal to suppose 0, minus 0, 0 plus 0. So, it is nothing but 0. It is nothing but 0. So, M value is the magnetic quantum number value is 0 for s orbital. L value is 0 and M value is also 0. For p orbital, for example, you take p orbital, p subshell. P subshell has L value is 1. So, according to this, it takes minus L to plus L including 0. So, minus 1 to plus 1 it takes. That means including 0, minus 1, 0, plus 1. The values are minus 1, 0, plus 1 for m values, ml values. So, these are 3, px, py, pz, or px, pz, py is 3. This is it is denoted by 2l plus 1 subshells in a orbitals in a subshell. So, number of orbitals in a subshell is 3. P subshell contain 2l plus 1, that is p is equal to 3. Px, py, pz, these are the orbitals. Px, py, pz are orbitals. P is called subshell. Subshell contains how many orbitals? P subshell contains 3 orbitals. What are the m values? Minus 1, 0, plus 1. So, it contains, each orbital contains 2 electrons, can accommodate 2 electrons. So, s orbital can accommodate 2 electrons. So, p orbital can accommodate 3 orbitals are there. So, each orbital can accommodate 2, 3 into 2, that is 6 electrons. Suppose you take L is equal to 2. L is equal to 2 is called d subshell. According to the magnetic quantum number, ml value takes minus 2 to plus 2. That is minus 2, minus 1 gradually decreases and gradually increases. Minus 2, minus 1, 0, plus 1, plus 2. Total 5 values, 1, 2, 3, 4, 5. 5 values. That means 5 orbitals are there. 5 orbitals are there. They are dxy, dyz, dx x square minus y square, dzx, dz square, dxy, dyz, dzx, dx square minus y square, dz square. So, 5 into 2, each orbital can accommodate 2 electrons. So, total 10 electrons can be accommodated by 5 orbitals, 5 d orbitals, which are present in the d subshell, whose L value is 2. Next one, F subshell contains, what is the L value for F subshell? 3. So, the L value is minus 3 to plus 3 up to minus 3 starts minus 3 and ends with minus plus 3. How these values are given? Minus 3, minus 2, minus 1, 0, 1, 2, 3. Total 1, 2, 3, 4, 5, 6, 7. 7 orbitals, 7 values are taken. That means, there are 7 orbitals. 7 orbitals are present in a F subshell. All these orbitals energetically equal. So, F subshell contain 7 degenerated orbitals. S subshell contain 1 degenerated orbital, 1 orbital. P subshell contain 3 degenerated orbitals. They are px, py, pz. And d subshell contains 5 degenerated orbitals, dxy, dyz, dzx, dx square minus y square, dz square. 5 are equally energetic. So, they are called degenerated orbitals. Degenerated orbital means orbitals of a subshell having same energy. So, d subshell contains 5 degenerated orbitals. F subshell contains 7 degenerated orbitals. So, how many electrons can be accommodated by this F subshell? 14 electrons. For 7 into 2, 7 orbitals, each orbital can accommodate 2 electrons. So, the 14 electrons can be filled in F subshell. So, let us see somewhat deeply. This is the how the magnetic quantum number occurs. This is the orbit electron revolving in circular path or elliptical path. This is the center. When electron is revolving in a path, the magnetic axis is perpendicular. Magnetic axis, magnetic field arises in a perpendicular way. Magnetic axis is magnetic axis of this one electron, s electron. When it is kept in the external magnetic field, this may be oriented. This may be circular path is oriented towards right or towards left, towards plus axis or towards minus axis. So, when it is tilted towards right, the axis also, this is z, axis, it also the perpendicular line is also shifted towards right. The foot of the perpendicular, if you see, that is +1, positive side +1. If it is in the external magnetic field, if it is tilted, if it is attracted, if it is simply modified, if it is then what happens? This is the when it is external magnetic field. So, the axis is again this, the perpendicular is foot of the perpendicular is takes -1. So, p orbital contains -1. So, if you leave the circular path, only magnetic axis you see, this is in z axis 0, in foot of the perpendicular you see this is +1, there is p p y, and the minus axis -1 p x. Mostly z orbital takes always on the z axis, in normal axis. In the absence of magnetic field, the axis is like this. So, the L value is 0 for the p z orbital. Similarly, if you see d orbital, the axis, I am leaving all these circular paths of the electron, only the magnetic axis I am taking in the external magnetic field. So, this is the p z. So, d z square takes 0 value, d z square takes 0 value, whereas x y. So, 5 orientations are possible when in the presence of external magnetic field. So, -2 put as the perpendicular, -1, this is the 0 normal, and +1 and +2. Total 5 values are taken d z square in the external magnetic field. So, this is the cause x square y square and x y takes the maximum values -2 or +2, and remaining will be taken -1 and +1, and z axis d z square is it takes 0 value, the ML value is 0 for this quantum number, ML quantum number is 0 for the d z square. So, this is the cause why these values are the ML values are like this. In the external magnetic field, the circular path will be deviated or deflected towards a positive axis or towards a negative axis. So, the foot of the perpendicular of the magnetic axis, which is perpendicular to the path of the electron, that is electronic circuit or electron, then that gives several values. Those values are quantized. So, those values are denoted by magnetic quantum number ML or M. For d orbital, their values -2, -1, 0, 1, 2. For s orbital, for s orbital only 1, 0. For a p orbital -1, 0, +1. Next one is spin quantum number. Spin quantum number or electron spin quantum number. It is denoted by S or ms. When electron revolves on its own axis, that is called spin. Like Earth, it revolves around the sun, and at the same time electron revolves on its own axis. Electron has some spin. Similar way, electron when revolves around the nucleus, in addition, the electron also revolves on its own axis. That is called spin of the electron. Spin of the electron. It may be two types of spin: clockwise direction spin. Electron may be anti-clockwise, may have anti-clockwise spin. If clockwise spin is there, this is the electron. If you consider this is the electron, if clockwise spin is there, that is S value is plus of, and it is denoted by upward arrow. Denoted by electron is denoted by upward arrow, which that means it has plus of value, plus of. S value is spin quantum number value, or ms value is plus of. And if it is anti-clockwise like this, anti-clockwise spin, then the S value is taken as given is minus of, it is downward, or it is denoted by downward arrow. These were proposed by Uhlenbeck and Gaudsmit. Uhlenbeck and Gaudsmit proposed these values. That means the spin quantum number generates a magnetic field. That is the reason spin magnetic nature derived from spin. magnetic nature as caused by spin is denoted by ms. So, ms values are two values only will be taken, because it has two types of spin, one is clockwise or anti-clockwise spin, 2 degrees of freedom. For electron, only 2 degrees of freedom. Degrees of freedom means 2 free movements. Free rotation is possible only clockwise and anti-clockwise. So, the values given by Uhlenbeck and Gauss-Schmidt for a spin quantum number are plus of and minus of. For a plus of is given for clockwise direction, clockwise spin, when electron is having a clockwise spin, that is denoted upward arrow, and anti-clockwise spin has when electron is there, that is denoted by downward arrow. It is a S or ms value is minus of. This quantum number tells only the electron, it do not depend on the other quantum numbers. Only spin quantum number describes only the spin of the electron. It only spin of the electron. It won't depend whether it is that electron is in the first orbit or second orbit or third orbit, in the S subshell or P subshell or D subshell. In anywhere the electron is there. So, the spin quantum number only tells the spin of the electron. So, it do not depend on the n value or L value or m value. L value depends on n, 0 to n minus 1. M value depends on L. L is equal to 0, 0, L is equal to 1, minus 1, 0, plus 1. But spin quantum number do not depend on all other quantum numbers. So, this bit is there in the first we have seen already. Let us see how this is very important for the entrance test. So, for example, S you know L value 0, P value P for P n is equal to 1, D L is equal to 2, F L is equal to 3 for radii reckoner, I have kept like this. For example, 3p1, 3p1. What are NLMS values for 3p1? 3p1, first electron p orbitals are 3, the electron is filled in a clockwise direction in first orbital. So, as it is n third orbit, n value is 3, for p subshell L is equal to 1, as it is in the first orbit m is equal to minus 1, the electron is minus 1, orbital is there, or electron is present in the minus 1 orbital, px orbital, that is. Yes, it is as it is clockwise direction, upward arrow. So, S is equal to plus of. For example, 4f2 you take, you know f orbitals are 7, minus the m value is minus 3, minus 2, minus 1, 0, 1, 2, 3. So, the 4f1, 4f2, this electron we are seeing the NLMS values for this electron. As it it belongs to fourth orbit, n value is 4, f subshell L value is 3, for f subshell L value is 3, and m value is minus 3, minus 2, this electron is in the minus 2 orbital. So, m is equal to minus 2, S is as it is clockwise direction, this electron is in the upward arrow, S is equal to plus of. For example, you take 3d7, n is equal to 3, the NLMS values for 3d7 electron, n is equal to 3, L is equal to as it is d orbital, L is equal to 2, m is equal to minus 2, minus 1, 0, 1, 2, but 7 electron, 1, 2, 3, 4, 5, 6th electron is starting pairing, 7th electron is also the pairing state. So, it is a downward arrow, that means anti-clockwise direction. So, S value is minus of here, is the anti-clockwise direction. So, spin quantum number is minus of, principal quantum number is 3, it belongs to 3, d orbital tells L tells the d orbital, L value is 2 for d orbital, m value is where the electron is there in 5 orbitals, that value gives the m. So, that value is minus 2, minus 1, m is equal to minus 1, S is equal to, because the electron is a paired electron, because it is in the pairing state, that means it is in the downward, it is in the form of downward arrow, that is in the form of anti-clockwise spin, it has anti-clockwise spin. So, S is minus of. For example, 2s2 let us see, 2 n value is 2, for s orbital L is equal to 0, for m value also minus 0 0 plus 0, that is m is equal to 0, s is equal to, because second electron it is a pairing, it is in the anti-clockwise direction, so minus half, s is equal to minus half. This you see already, this is given in the question bank. 3 dz square 1, 3 dz square 1, n value is 3, okay. L value is 2, because d orbital L value is 2, m value is 0, m value is 0, because 0 axis only is z square axis d orbital is dz square, that is takes the always z axis takes pure z axis takes the 0 value in the ml values. So, dz square, the electron m is equal to 0, 1 electron is there, not 2 electrons. So, pairing not there, one is first electron is in the clockwise direction, let us assume s is equal to plus of, s is equal to plus of. So, for this, for our bit, the answer is n is equal to 3, L is equal to 2, m is equal to, because specifically he asked z square, d simply 3 d 1, then minus 3, then minus 2. So, if it is 3 d 1 electron, the L value is m value is 1, but he specifically asked 3 z square 1, for 3 z dz square this is 0, because when in the external magnetic field, in the absence of magnetic field, it occupies the axis occupies z square z axis. So, that takes the values 0, that is considered 0. So, m is 0, s is equal to plus of, because in the clockwise direction. So, let us see, these are useful to do some bits. Number of electrons in a subshell, number of electrons in a subshell, 2 into 2l plus 1, because you know 2l plus 1 orbitals are there, each orbital can accommodate 2 electrons. So, 2 into 2l plus 1, or you can say 4l plus 2. Number of electrons in nth orbit, number of electrons that can be accommodated in the nth orbit. You know n square orbitals are there, in first shell only one orbital is there, second shell 1p and 3, 1s and 3p, total 4 orbitals are there, 2 square, that is equal to 2 square, and n is equal to 3, n is equal to 2, sorry, n is equal to 3, how many orbitals are there? 3 orbitals, s orbital, 3 subshells, s orbital, 3 p orbitals and 5 d orbitals, total 9, 9 is nothing but 3 square. So, each orbital can accommodate 2 electrons. So, n square orbitals are there, in the n square each orbital can accommodate 2 electrons. So, number of electrons that can be accommodated in an orbit, in a principal quantum or principal orbit, that is 2 into n square. N square is orbitals present in the nth orbit. 2 into n square, why you have kept 2? Because each orbital can accommodate 2 electrons. So, the number of electrons that can be accommodated in the nth orbit is 2 into n square. So, number of orbitals in a subshell 2l plus 1. For example, s orbital, L value 0, 2 into 0 plus 1, only one orbital. P subshell, P for L is equal to 1, 2 into 1 plus 1, 3, px, py, pz. For D subshell, L value is 2, for D subshell L value is 2, 2 into 2 plus 1, 2 into 2 is 4, 4 plus 1, 5 orbitals will be there. So, in general, in the form of formula, we can write number of orbitals in a subshell equal to 2l plus 1. Number of electrons in a subshell is equal to 2 into 2l plus 1, 2l plus 1 into 2. Each orbital can account 2 electrons, so 4l plus 2. Similarly, number of orbitals in the nth orbit is n square. Nth orbit is n square, electrons are 2 into n square. Okay. So, already while discussing the quantum numbers, we have seen, but for recall all the formulas are written here. Now, let us put advanced manner for the entrance test. So, let us see the angular movement of electrons in the orbit, subshell, orbitals and electrons. For example, angular momentum of the orbit, that is principal quantum number, pradhana kashya, principal quantum number. So, MVR is equal to NH by 2 pi, already in Bohr's atomic theory we have seen. For K shell, n is equal to 1, 1h by 2 pi, 0.5h by pi. For L shell, the angular momentum is 2h by 2 pi, h by pi. For M shell, n is equal to 3, 3h by 2 pi, or 1.5h by 3 by 2 is equal to 1.5h by pi. For M shell, the angular momentum is 4h by 2 pi, 4 by 2, that is 2h by pi. So, angular momentum, when he asks of an orbit, so you have to see nh by 2 pi. You have to observe the nh by 2 pi. You put you substitute n value, so that you will get the angular momentum of that particular orbit. Orbital angular momentum. So, this orbital quantum number, you know, orbital azimuthal quantum number, orbital angular momentum. So, electron in the orbital has some angular momentum. That angular momentum can be calculated like this by using this formula. The derivations are in quantum mechanics, so you need not bother about the derivations. So, root over L into L plus 1 h by 2 pi. L value for s orbital, s sub shell you can say L is equal to 0, 0 into 0 plus 1 h by 2 pi, or simply h by 2 pi. 0 into 0 plus 1 is equal to 1, root 1 is equal to 1, so h by 2 pi. For p orbital, L value is equal to 1, L value is equal to 1. So, root over 1 into 1 plus 1 h by 2 pi. For p subshell, a dumbbell shaped subshell, this is spherical subshell, dumbbell shaped subshells, orbitals, root over L into L plus 1 h by 2 pi, or h by this is 2, root 2, root 2 by 2 is equal to 1 by root 2, h by root 2 pi, h by root 2 pi. For dumbbell shaped orbital, what is the orbital angular momentum? H by root 2 pi. For d orbital, d subshell, the L value is 2, root over 2 into 2 plus 1 h by 2 pi, that is how much? Root 6 h by root 6 into h by 2 pi, root 6 into h by 2 pi. For f subshell, root over L into L plus 1, 3 into 3 plus 1 h by 2 pi. 3 into 3 plus 1 is nothing but root 12. Root 12 can be written as 4 into root 4 into 3. 4 is nothing but 2. So, when it comes out, so 2 cancel out, root 3 h by pi. So, these are the this will be useful for NEET or MSET examinations, for JEE examinations. To find out the angular momentum of the some p orbital or double orbital or d orbital or complex shaped orbital f orbital. So, that you can use this formula, so that you can calculate the angular momentum, orbital angular momentum values. For magnetic quantum number, magnetic angular momentum, to find out the magnetic angular momentum, ml into h by 2 pi. ml, for example, m is equal to 2, minus 2 or plus 2, modulus 2, modulus value you take, 2 into 2 h by 2 pi. What is m value is 2, for which orbital m value is 2? So, it may be minus 2 plus 2, that is any orbital, d orbital, you can think it is a d orbital, 2 h by 2 pi or h by pi, 2 to cancel out h by pi. Similarly, spin quantum number, spin angular momentum, S, it is denoted by S, angular orbital, these two are very important for JEE or NEET purpose. L value, it is S value, capital S. Capital S is also given is a root over S into S plus 1 h by 2 pi. For electron, spin angular momentum can be calculated by using this formula, root over S into S plus 1. S is equal to spin modulus spin value of, you can put half into half plus 1, half into half plus 1, or you can write 3 by 4, 3 by 2, this is 3 by 2 into 1 by 2, 3 by 4 h by 2 pi. By 2, this is you can 4 is nothing but root 2, 4 is equal to simple 2. So, you can write root 3 h by 4 pi, root 3 h by 4 pi, or root 3 by 4 into h by 2 pi. So, a spin angular momentum value is fixed, that is mostly 3 by 4 root 3 by 4 into h by 2 pi. So, now let us now discuss the bits already given the answers, how the answers came, let us know. So, which quantum number describes spatial orientation of the orbital? So, in direction of the orbital will be ml. ml ante what is the ml? ml means magnetic quantum number. How many electrons can be accommodated in m shell? M is n is equal to 3. N is equal to 3 is called n is equal to 1 k shell, n is equal to 2 L shell, n is equal to 3 m shell. So, n is equal to 3 m shell, 2 into 3 square, 2 into 3 square, 2 n square rule. Number of electrons can be known by 2 into n square, n is equal to 3. So, 2 into 3 square, that is 3 square is 8, 9, 9 into 2 18, this is C. Number of orbitals present in nth orbit, number of orbitals present in the nth orbit is n square orbit. Electrons are 2n square. Number of orbitals present in a subshell 2l plus 1. Understand? So, the answer is now orbitals in the nth orbit is n square, this formula. G subshell contain dash number of orbitals. So, you know S contains 1, P contains 3 orbitals px, py, pz, d orbitals contain 5, F contains 7, G contains, what is the value of G? L value is for G 4, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. So, total 2L plus 1 values, 2L plus 1 values means 9 values, 9, 2 into 4 plus 1, 2 into 4 is equal to 8, 8 plus 1, 9. So, if G subshell is there, it will have 9 orbitals. Which quantum number do not depend on the other quantum numbers? You know, spin quantum number only tells about the electron, spin of the electron, but do not depend on the quanta, that is shell, orbital or orbit, subshell. Anything, any quantum number do not depend, only it depends on the electron, spin of the electron. So, ms value is the correct one. Number of degenerated orbitals, equally energetic orbitals in the F subshell. So, degenerated orbital means several orbitals present in a subshell are equally energetic. So, they are called degenerated orbital. S contains only 1, P contains 3, px, py, pz, D contains 5, dxy, dyz, dzx, dx square minus y square, dz square, and F contains 7. They are complex in shape. So, D is the correct one. F contains 7 orbitals. Which one of the following is correct set for the 3D z square 1? Already it was explained. N is equal to 3, d orbital L is equal to 2, but it is a dz square, 3 dz square, m is equal to 0, 1, first only one electron is not 2. So, only one electron, so it is a plus of clockwise direction. If 2 is there, second electron will be in the anticlockwise, same t dz square orbital. If 2 is there, then you can write minus of. Okay. 3d z square 1, the first electron, the spin quantum number is plus of, it is clockwise in direction. So, it is denoted by upward arrow, its value is plus of. So, understand? So, B is the correct one. Why it is not correct? Let us see first, let us discuss. N is equal to 3, okay. L takes at least one value less, okay, because n should not be equal to L, up to n minus 1 values only it will take L 0 2. So, 2 is okay, but m depends on L, minus 2 2 plus L, but here 3 is there. So, it is wrong. It is correct, we say. Already let us see this 2, n is equal to 2, L is equal to 3. If n is equal to 2, L should take up to 1 only, 0 1 only. So, L is equal to 3, here simply it failed, this is failed, you need not bother about the all others. Here if you see n is equal to 3, L is equal to 0, it is okay, L value is less than n, m as equal to L, okay. S is equal to plus of or minus of, but one it won't take 1. So, it should be either 1, either plus of or minus of. So, here in spin quantum number it is deviated. So, the B is the correct answer for this question. Orbital angular momentum of the dumbbell shaped orbital for p subshell. Dumbbell shaped orbital is nothing but p subshell. Double dumbbell is d. For p subshell, what is the L value? L value is 1. So, what is the orbital angular momentum? Orbital angular momentum is equal to root over L into L plus 1, root over L into L plus 1 h by 2 pi. L value is 1, 1 into 1 plus 1, that is equal to root 2 into h by 2 pi. So, root 2 it cancels out. So, it some root is 2 is left, h by 2 pi is this. This is the answer. Let us see if you want this is you see h by 2 pi, h by 2 pi for angular momentum for the L orbital h by root 2 pi, h by root 2 pi, L 1 into 1 h by 2 pi is 2 root 2 sir this one. So, root 2 into root 2 you can write, one root is cancelled out, root 2 h by root 2 pi. So, this is the thing. Now, so is the next with more information I will come in the next video. Thank you. Subscribe for more information again. Thank you very much.